Hey everyone, and welcome to episode 664 of People Behind the Science. I'm your host, Dr. Marie McNeely, and this week we are excited to be rebroadcasting our interview with Dr. Shawn Domagal-Goldman, originally published on February 20th of 2015. Listeners, if you have not met Shawn yet, he is a researcher, leader, and dedicated science communicator. In his research, he and his collaborators used different tools to measure the ratios of isotopes and the abundance of planetary gases on planets both within and far beyond our solar system. These data can be used to detect signs of extraterrestrial life and to help us learn more about some of Earth's most ancient rocks. So listeners, get ready to learn more about Shawn and his research in this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. I am thrilled to be here today with Dr. Shawn Domagal-Goldman. So welcome to our show, Shawn. How are you?
I'm doing great. How are you doing, Marie?
I'm fabulous. Glad to talk to you today and excited to introduce you to our listeners.
Well, I'm happy to be here.
Fantastic. Now, listeners, Shawn is a research space scientist with NASA at the Goddard Space Flight Center. He received his master's degree in earth sciences from the University of Rochester and his PhD in Astrobiology and Geosciences from the Pennsylvania State University. He also previously worked as a research associate at Penn State, a research associate in the Virtual Planetary Laboratory at the University of Washington, and he also has served as the NASA Astrobiology Management Postdoctoral Fellow before accepting his current position. Now, Shawn is here with us today to tell us all about his journey through life and science. So, Shawn, today we are excited to get to know you, both as a scientist, but also as a person. So can you kick it off with telling us what you like to do with your time when you're not doing science?
Well, these days I do a lot of parenting because I have a 16-month-old girl at home, and that's what I enjoy doing with my time, too. But in general, I'm the type of person that doesn't dislike a lot of things. You know, I sometimes will blog about baseball. I'm always a nerd no matter what I do, so when I blog about baseball, I blog about the statistics and stuff like that. But, you know, I play basketball, I play water polo when I get the time, although I have less time for that now than I used to. I have a lot of stuff that I find fun, and I try to do as many of them as I can. I like video games a lot. So, I don't know, it depends on the day, and it depends how much time I have. But these days, it's a lot of feeding milk and cleaning up messes, changing diapers and things like that.
Gotcha. All the fun things.
Yeah, all the fun things.
Well, wonderful to hear about how you spend your time when you're not at work, Shawn. I think definitely having a 16-month-old will keep you quite busy. So trying to squeeze in any of those other leisure activities when you get a chance sounds great. Now, we're going to dive into your scientific side next. So can you take a minute to tell us how you describe what you do at work to someone who might not be in science?
Yes, I absolutely can. So the simplest way I explain this, and sometimes people don't believe me when I say it, is I look for ways to look for alien life. I think about ways, whether it's with a mass spectrometer that would measure the ratios of isotopes on the surface of Mars, or whether it's a spectrograph that would measure the abundance of gases on a planet around another star, how life could affect its environment in a way that would leave signatures that were totally different from the things that non-biological processes could do, and ways we could leverage that to look for life beyond Earth. And, you know, it's funny, I was out with a friend of mine at a bar once, and I said this to a group of people that we were talking to, and my friend said, oh, he made that up. He makes stuff like that all the time. But it's the truth. I mean, that's sort of what we do. It's one of the reasons that NASA is building a lot of science spacecraft these days. A lot of them are either geared towards studying Earth's environment and how we might be altering it, and a lot of the rest of the missions that go beyond Earth are to study whether or not we're alone in the history of the cosmos and the history of the planets in our solar system. And these things are all related. You know, by studying climate change, we understand better how our biosphere, including us, but not limited to us, affects the atmosphere. And by studying detailed environments on Earth, we learn how life affects the chemistry of rocks and of soils. And these things feed forward into our search for life beyond Earth, too.
Well, this is intriguing, Shawn. I think a very interesting area of research and something a lot of people can relate to, this big sort of looming question of, are we alone out there? So do you have a sense or a guess of when or if we'll be able to find life outside of Earth?
This is one of those questions where it's like, you can kind of judge the age of the person answering it by their answer. Like, I would say it's going to be 20 years.
All right.
But in general, the older someone is, if they're in this field, the sooner they think it's going to happen. Because everyone thinks it's going to happen before they're going to retire, right? Or before they're going to die or whatever.
Some element of wishful thinking.
Yeah, exactly. I would say about 20 years, give or take 10. But part of what's exciting to me is that I think we're actually at the point now where that's not a crazy number to toss around. Whether it's searching for life on Mars, whether it's searching for potential habitable environments in the outer solar system, like these icy worlds like Europa that have liquid water in the subsurface, or whether it's searching for life on planets beyond our solar system, planets orbiting other suns, essentially. We have an approach to find life on each one of those worlds, and any one of them really could happen over the course of the next 20 years. The one I work on the most is the exoplanet one, the one for the planets around other suns, and so that's one I get the most excited about, and I'm pretty confident we can do that in 20 years. But any of them realistically could happen in that time frame. And this is part of what gets me really excited is, if you ask me, what do I think? Like, if I say this at a bar or, if I meet someone and I say, this is what I do, the response is often like, oh, you look for aliens. Have you found any?
Right.
And my answer is, well, like right now, your guess is as good as mine. Mm-hmm. As a scientist, I don't have the data from which I can make that assessment right now. So it's right now more of a philosophical question. But we're on the verge of being able to turn that into one that we can apply the rigors of the scientific method to. We can start building hypotheses. If life exists on planet X, then we shall find Y. And then we can go look for Y and see if we find life on that planet.
Well, this is a fascinating area of research, Shawn, and I think it's easy to get excited about. It's something, like I said, that speaks to a lot of people, these big, almost philosophical questions that science is now getting to the point where we can start getting closer to an answer to them. So I know it's easy to get motivated by the questions in science, the research that you're doing, but I love to talk to scientists if they have a favorite motivational quote or a saying. I'm a big quote person, so can you share one of your favorites with us today?
Honestly, the quote that gets me going every day is one that my mom, actually, when I was a baby, stitched into, I don't know what you call it, like one of those like tapestries, like, like moms and aunts and grandmas, like, stitch these, like, sayings or, like
a quilt or something, yeah.
Yeah, and so I have one that I've actually got hanging in my baby's room now that my mom, I think, made for me that says, what you are is God's gift to you, and what you become is your gift to God. And I'm not a very religious person, so whether you believe in God or not, I think the sentiment can apply. And, to me what that says is I've been very fortunate in a lot of ways. On the very grand scheme, I'm fortunate to be alive. Knowing the course of evolution, I'm fortunate to be an animal that has a brain that can make tools with my hands.
Right.
Right? I mean, and if you look at course of human history, this is, in my opinion, a great time to be alive. Getting more specific, I had a lot of things that really went my way when I was a kid that enabled me to do something that I really love, which is my job looking for life beyond Earth.
Well, that is a wonderful quote. Certainly keeping you grounded, having this big overall perspective. I love that.
Right. But then what do you do with that, right? And that's where the second part comes in. It's like, if I'm so lucky to have the opportunities I've had, then the second part of that is what I give back and how hard I work to do something with that opportunity is really important to me. So in terms of motivational, that one probably is the number one for me.
Fantastic quote, Shawn. I love to hear everyone's individual takes on quotes and how people interpret them. And I think this one has a great application for your life, it sounds like, and just in general in science, giving back to the world through the work that you're doing. So fascinating to hear what motivates you, what keeps you going. And now I'm curious to take a little walk down your scientific journey. So we're going to start by talking about some of these people that you've encountered who really served as role models or mentors to you. So can you share a few?
This is one of the questions that I really struggled with. And it's not because there's a lack of role models. For me, I've just had so many. From my parents, honestly, my brother, who is not a scientist, my little brother is an entrepreneur who lives in Silicon Valley and does like business plan development. Seeing the way he thinks about branding, seeing the way he thinks about how to approach problems and networking and things like that is totally different than the types of expertise I get when I interact with my colleagues and peers. He just comes from a different mindset. And a useful one, it's just he's trying to think in ways that we're not traditionally trained to think in as scientists. And so I learn a lot by talking to him about what he does in his job and his day-to-day life. And of course, I've been incredibly lucky, and I mean this, lucky to have great advisors. We, to some extent, choose our advisors, when we apply to grad school or postdocs or whatever. I mean, every job you go into in the sciences until you get a permanent position, you have someone who has a tremendous impact on your day-to-day and your long-term happiness and mental and emotional health.
Mm-hmm. And it feels like a blind date when you're going in those interviews. You have no idea how it's going to work out, right?
Yeah, you're like going on a blind date with a pre-arranged commitment for like 2 to 4 years, depending on the job.
Right.
So it's like going on a blind long-term relationship.
Right.
And that's where the luck comes in. And for me, I've looked out between Jim Casting, who is my advisor at Penn State. Before then, Ariel Lombard, who was my undergraduate advisor, and then Victoria Meadows, who was my postdoc advisor at the University of Washington, and then Michael New and Mary Wojtek, who were my advisors at NASA headquarters when I was a postdoc there. Every single one of those people has been incredibly beneficial to my career. They've fought very hard for me, which is really important for a student or a postdoc trying to find their way in this highly competitive world. And they've just been incredible people on a personal level. And so I could talk to you probably for about a half hour about how each one of those people has been really great for me on an individual level, but I don't want to single any one of them out because they all have been tremendous.
Gotcha. Well, what a politically correct answer. I love that. And I think a lot of scientists have this experience where they just have so many mentors, and it might not even be someone that they had that formal sort of long-term blind date relationship with. It might be just someone that was serving as a mentor who was not their immediate advisor. So interesting to hear about these people who really helped shape you, shape your career, all the way from family members like your brother through all these people that you were able to work with. So great to hear about these people who've inspired you. But now I'm curious to hear about what got you started down this path to begin with. What really sparked your interest in science, and particularly in space?
I've always kind of been into science. I've always enjoyed sort of the challenge mentally, and I think I kind of wanted to be a scientist. I can't really put a date on it, but the thing that made me specifically interested in the thing I studied was I read a couple books about the possibilities for Mars, for the potential for there to have been life in the past there, or maybe even if things break a certain way for us to explore Mars with humans, or maybe even colonize it. And the power behind that series of questions, for me, was just too big for me to ignore. That's sort of how I got into this field and started looking at the question of, are we alone? I really love that. And from there, I think the best way to probe that question personally is to look to life on planets beyond our solar system, just because the sample size is larger. And so it kind of progressed from this like, oh, hey, Mars is awesome, to aliens seem really cool, to what's the best way to go after the search for life beyond Earth. And that's where I've ended up on exoplanet research as my sort of little specific area that I work on.
Very interesting. So can you tell us a little bit about how you got to your current position at NASA from this early interest in science and space and these big questions you're asking?
Well, in terms of how I got to that position, I'll be frank, I was helped out a lot by people that I worked for and worked with that really pushed for me on an individual basis. And if there's any scientists out there that are early in their careers, whether an undergraduate thinking about going into graduate school, or you're a graduate student or a postdoc, my best advice is, well, a few things. One is you have to cast a broad net, and I did that. I never said I'm going to work at NASA and that's it, that's what's going to happen. I kind of set myself up so I could get a series of different positions, and this is the one that happened to land for me. And that broad net is really important because we have so many people out there that it's about more than just whether or not you're qualified for that job.
Right. It goes way beyond the resume, right?
Yeah. If there's 100 applicants, you're going to have 10 or 20 people that are really good and that are great for that job. It's in many ways about the fit, and that's about luck. And the only way you overcome something you need to get lucky to land is you just roll the dice a bunch of times. So that was part of it. And then how I ended up at NASA specifically just had to do with the things I was doing a couple of years ago at NASA headquarters and pressing people within the agency and them really valuing my specific skill set. I mean, I could go into more detail, but the best advice I could give is really just to cast a broad net and to find good advocates for you. Finding good advocates for you is incredibly important.
Certainly. Well, I think you brought up some really important points in terms of the career search of a scientist. You're absolutely right. There are so many very, very highly qualified, incredibly smart candidates out there that oftentimes, it's hard to stand out of the crowd. You just have to keep applying to different places, cast this broad net, as you said, and you'll hopefully find that place that's a great fit for you.
I don't know about you, Marie, but I shouldn't say this because I don't think it's heartbreaking when someone leaves the field, because I think there's lots of great things people trained in science can do with their lives other than, the classic lab researcher. But when I see someone who really wants that position for themselves and they've made that conscious decision, they want to be a researcher the rest of their lives, and they're smart enough and they're capable enough, and they should be able to do this, but there's just not the job out there for them at the time they're applying for jobs, they leave the field. That's one of the most heartbreaking things, and I see it so often. It eats at me.
You're absolutely right. There's a lot of sort of what we call non-traditional careers now for scientists out there. And if that's what people are excited about, absolutely go do it, give it a try. But it is hard to watch people who are so excited about pursuing this more quote unquote traditional career in science be turned down again and again and again. So it's one of these things where you do have to keep trying. You have to be persistent, and hopefully things will work out. Keep your fingers crossed for luck, I think.
I think that, not to drag this one question on too long, but I think that's the one other thing about how I ended up at NASA is I never bought into the argument that you're either a tenure-track faculty or you're nothing at all.
Mm-hmm.
I would have been very happy working on science policy issues, and I would have been happy in a government lab working on spaceflight missions, which is where I ended up. And I would have been happy with a faculty position, but I didn't set my mind on the faculty and only the faculty, and that was all I was going to accept. And that's, I think, part of the reason I ended up with a job that I'm very, very happy with. And I think if there's one thing I could change in academia, especially in science, it would be to train people to do more than just clone the faculty members that are training them.
Right. Or we need to get our bosses to hurry up and retire, right?
Yeah, exactly.
Very, very interesting story, Shawn. So can you dive into a little bit more detail? So we talked about how you got to where you are. Tell us a little bit more about one of these projects that you're currently working on that you think is just the most exciting.
The project that I literally almost teared up the other day when I was thinking about the fact that I'm working on it is this mission that we've been exploring at Goddard called Atlas. And we haven't really been pushing it in the public yet for various reasons, but people will start hearing about it over the next couple of years. Atlas, it's an acronym because everything at NASA is an acronym. It stands for Advanced Technology Large Aperture Space Telescope, which sounds a lot more boring than it is.
You guys have great acronyms, though.
We do have a lot of great names. This one would eventually have some other name if it happened. That's sort of our internal name for it. But the idea is we're going to build a large telescope that's 10 meters across, so that's like a first down in football across, put it in space, and give it the technology that it needs to readily image, so take a picture of planets around other stars, and have the capability to look at that picture and analyze it to see if there's any evidence of life on that planet. And this is something that when I started off in grad school, I heard that this is a possibility, and I thought, well, that sounds pretty awesome. And when I was in grad school, I imagined that this might happen one day with a 4-meter telescope, half the size of what we're talking about, with 1/10 the capability of this thing. And the fact that I'm working on this, even though it's just a concept mission at this point, the fact that I'm working on it, that it has so much chance of happening, it far exceeds any expectations I had when I started getting involved in this field. It just blows me away. And it's the type of thing that I will work way more hours than I probably should on it just because I love it so much. That's my thing right now.
That is an amazing project. And I know a lot of our listeners out there are probably familiar with images coming from space telescopes like the Hubble telescope. Can you give us a little kind of ballpark idea compared to something like the Hubble telescope? How is this one going to be different in terms of scale, quality of images, capabilities, things like that?
Some people have actually called this Hubble HD or something like that.
Okay.
So there's two main science things that would come out of this telescope. The first is the search for life. The second is following up on Hubble. This would actually be looking at sort of the same colors of light that Hubble looks at. It would look at, the visible light we see with our eyes. It would look at the ultraviolet light that we get shielded from, or else it would cause skin cancer, the ozone shield and that. And it looks at the infrared light. So that's what Hubble looks at. This telescope would actually look at the same colors. So it would be doing a lot of the same science that Hubble does, but it would be doing it with a much bigger telescope, right? So it would be, in terms of area, it would be 10 times as big as Hubble.
Oh, wow.
And so the images would be spectacular. If you've seen any of the astronomy art, if you get the NASA calendar, and you get these unbelievable pictures of these star-forming nebula and other galaxies and things like that, most of that stuff comes from Hubble. And this mission, if it flew, in addition to doing the search for life, would be doing that with a difference in sort of resolution that's similar to the difference between a standard definition and a high definition television. So it would be doing the art that Hubble is doing in terms of, I would have this amazing poster on my wall of these, nebulae and galaxies, and it would be answering these like huge philosophical questions about are we alone in the universe and what's the history of the universe? And to put it in scale, it's way bigger than Hubble, and that's not just like a bragging thing, like who's got the biggest telescope.
Mm-hmm.
It's also like because it's bigger, it actually brings about a lot of technical capabilities. And the other thing is Hubble was designed before we knew these planets were out there around other stars, and certainly before we knew there were any potentially habitable worlds around other stars. So Hubble wasn't really designed around the concept of taking pictures of the planets. Hubble was designed to look at galaxies and to look at these star-forming regions and things like that. It wasn't really designed with planet imaging in mind, whereas this mission would. Hubble can't do that part at all, whereas this mission would be able to.
Well, this sounds incredible. Just phenomenal science, plus just the best Christmas cards ever I think you're going to have once these images start coming back. That is an amazing project.
Yeah, I can't wait. I drink a lot of coffee.
I think you're at a Starbucks right now, right?
I'm at Starbucks right now. Yeah, you might hear the traffic in the background.
Right. Excellent. Well, Shawn, this sounds like just an incredible project to be working on. Certainly easy to see how you could be so excited about what you're working on right now. And I think we've talked about all the great things about getting a career in science and the work that you're doing. We haven't yet touched on some of your struggles, some of these challenges that you faced. And I think in the world of science, oftentimes you see a rosy picture because you only hear the success stories. You only see the end point of a research project. But I think there's so many bumps and mishaps along the way that a lot of people don't hear about. So can you take us to a point in your career where you were struggling with something or you just had one of these major failures and tell us what happened and how you got through it?
I'll give a broad one and I'll give a specific one. The broad one is related to this problem we talked about a little bit ago of, how flooded the job market is in the sciences right now and how competitive it is. And the scientists that are sort of a generation ahead of me, they viewed their postdoc period after they got their terminal degree, but before they landed a permanent job, as the best period of their careers because they didn't have to worry about anything but research.
Mm-hmm.
And postdocs today, I tell people the job of a postdoc is to get another job.
Right.
And, it's so stressful and you're making more than you did as a grad student, but, you look at your friends. Like I got a degree in geology, right? So my friends from grad school are working for the oil industry. They were making a lot more money than I was. Not that money's important. If I was in it for the money, I'd be in the oil industry, first of all.
Mm-hmm.
But when you're a postdoc, you're struggling sometimes financially. These things affect your personal life, and that's incredibly stressful. So that's the general. The specific is as I was going through that sort of period that most scientists these days have to go through, I had a paper that I'd been working on for like 2 or 3 years. And I don't want to go into the details, but I had someone come onto that paper because they had independently discovered the same phenomenon that I discovered.
Oh,
and
no.
then once they were on the paper, decided they should be first author of the paper. And if you're listening to this and you're not a scientist, this is like a major argument.
This is a friend-ending faux pas.
Yeah. It's like when you do research, there's this list of authors, and the first one is presumed to be the one that contributed the most to the work. And having this person come on that we invited on the paper decided they were going to be first author. And then when we said, okay, we sort of reached out an agreement of authorship of if X happens, then I'll be first author, and if Y happens, then you'll be first author. And it turned out that the conditions existed such that according to our agreement, I would end up as first author. And at that point, when I sent out the emails explaining this, the other person involved didn't respond and just left the paper and decided to write up the work on their own without telling us. And so when you're at that stage in your career, when you're just sort of fighting for survival, every single one of these papers matters a lot. And the larger the impact of the paper, the more you really want it for yourself. It turns even not selfish people into very selfish people because of the competition in the market. And when you try to be nice and then you end up getting sort of posed by that, it's really hard on a personal level. In the end, what ended up happening and how I resolved it is that other individual published their paper and I published mine. And mine came out a little bit later because I wanted to be careful and make sure we had the story right. I described some of the differences between our results and theirs. And this is how science ultimately progresses. Even this is a very, very personal thing, right? Like the bond between me and this other person was not good. But in the literature, it's just a fact. They have their results and I have mine, and we both published them. They both are out there and people can compare them to each other. And ultimately, when I take the personal stuff out of it, it's probably a good thing that we both published on this somewhat independently, because we were looking at it from fairly different perspectives, and we came to somewhat similar conclusions. And where we had different conclusions, people can read these papers and figure out why we came to those different conclusions. And I think ultimately that's pretty healthy, even though it was really hard on me in the heat of the moment. I think the end result was okay. And I ended up with a job, and this other person has a job. So on a personal level, it's okay. But wow, it can be really gut-wrenching in the heat of the moment when these sorts of arguments crop up.
Certainly. Well, good to hear that everyone made it through and continued their career. It wasn't a career-ending moment for anybody. But I think you're absolutely right. Publishing is one of these major stresses in science, particularly now in this very competitive market. Like you said, every publication matters, and people are fighting to get out there and publish first and fighting to get ownership of these publications, of these results of research. But I think you're absolutely right. It does cause some internal strife and just problems between groups when trying to pinpoint that authorship list. So great example to bring about and talk with us today.
And, there's no rules, right? I mean, we're not told.
There's no training either, right?
Yeah, you just kind of learn by doing. And sometimes we learn by screwing up with each other, too. And that doesn't help the person screwing up or the other people on the paper. It's really hard.
Right. And I think it's so important to think about these things as you're considering a career in science, things to just kind of keep in the back of your mind. Because like we said, there's no real training in it. You don't really talk about it. It's something you learn as you go along. So great to hear about one of these tough times and how you got through it. But we don't just want to focus on the difficult points, the tough times. Can you tell us next, Shawn, about a success story, one that's really meant a lot to you?
So the thing that jumped to your mind first, because I was working on it so hard, was sort of the day I found out that NASA would offer me a job. But I think backing up from that, the first paper that I got accepted in the literature, I felt like I was real for the first time as a scientist. Again, for those that are listening, you submit a paper and the editor of the journal says, okay, yeah, we'll consider this. We'll think about it. And then they send it off to some other scientists, usually senior scientists that are faculty or at least postdocs. Depending on the field you're in, they'll go to one. As few as one, no fewer than one, but as many as 4 or 5 other scientists. And we're trained as scientists to be really brutal, just horrible to each other when we review each other's papers. And so, of course, I got my papers back, the first couple I submitted, and they were just totally marked up. And that's another struggling point, right? It's you spend 2 years putting a paper together, you send it out into the wild. It is your love and your passion and your blood, sweat, and tears are into it, and then it comes back usually months later.
Just shredded, yeah.
Just shredded, covered in red. And that's hard, but what ends up happening is, you go and you walk away from your desk and you're angry about it, you come back. But eventually you fix what was wrong with the paper, because usually you screwed something up. I mean, very few people write perfect papers on their first try.
Mm-hmm.
And so you fix it, you send it back, and sometimes it comes back again with a little less red, and you keep going back and forth. But when that paper gets accepted for the first time, and in the meantime, you've been doubting yourself. You're thinking, am I cut out for this? Am I just really horrible at science? Am I horrible at writing? Are my techniques bad? Why am I such a miserable failure at life and everything? Until that paper gets accepted, and then you're oh, I can do this. I can be a scientist. You see your name.
I have been validated, yeah.
Yeah, you see your name at the top of the paper, and it's hey, that's me. And it places you in this context. All of grad school, in addition to doing all this research, you're reading all these other people's papers. And sometimes you have a personality associated with people you've never met because you've read 10 or 20 of their papers, and you just know them by their last name,
right?
Clark et al. Or whoever et al., right? And now you're part of whoever et al. And getting to that moment in your career is just indescribable. To me, it's like getting called up to the majors for a baseball player. You're finally in the big league. You made it.
Yep, you made it. I love that. And I think I felt the same way that first time I got an acceptance notice, that this paper that I'd been slaving over. And of course, the first submission was miserable, and they get better each time. But yeah, I think you're absolutely right. When you get that acceptance and you think, I am a published author in a peer-reviewed scientific journal, I think that is huge. So great success to share with us today.
And I think it happens every time everybody submits. But that first one, the lows are the lowest and the highs are the highest,
Absolutely. Well, great example of a success. And I think so important for a lot of scientists. That first paper, I'm sure a lot of people can remember when they submitted that, when they finally got it accepted. So great example. And I know scientists keep so busy writing papers, doing their research, all these things that they're excited about. And it doesn't always leave a lot of time for everything else in life. And often a lot of scientists mention that they don't get enough time to read quite as much as they'd love to. But I get so many great book recommendations. So can you share one of your favorite books with us today, Shawn?
Yeah, there's too many to list. I'm going to cheat here. I'm going to give you 2, but I'm really going to give you 5. So one is Where the Sidewalk Ends, Shel Silverstein. And, any assigned scientist really should have listen to the Mussins printed out and like stapled on their desk or their like office door or whatever.
I'm going to have to revisit that one.
Yeah, it's like listen to the Mussins, listen to the don'ts, listen to the impossible, the couldn't, won't, something like that. And then it says, listen to the never has and listen close to me. Anything can happen, child, anything can be, right?
Yeah.
I'm kind of butchering it a little, but it's like, listen to all the doubters, but realize in the end, like, you can do it. Which I think is a great way to approach science, by the way. And then the other one is the Game of Thrones books. I'm just totally engrossed in those right now. Actually, it's the Song of Fire and Ice. Mm-hmm. The ones that the Game of Thrones HBO series is based on. I am rereading them, even though they're like, I don't know how many thousands of pages long altogether, because I'm just in love with them. So yeah, my favorite authors are Shel Silverstein and George R.R. Martin, which are about as different as you can get on the spectrum of like innocent to like totally bloodbath war people.
Well, you got to have a little bit of both in your life, a little bit of balance, right?
Yeah, life is a balance, right?
Great recommendation, Shawn. I will put your list out there on our website for our listeners to check out. And I think in addition to some of the great opportunities you have for research, we mentioned these different places that you went for your training. I think scientists get a lot of opportunities to travel. So can you think back now on all the places that you've been for science, Shawn? And can you tell us about your favorite place?
So my favorite place is probably San Salvador Island in the Bahamas.
All right.
I've gotten the chance to go to a lot of cool places like Hawaii, and I've been to Europe a couple times, and I've been able to travel a lot. But San Salvador Island, I went to a couple times in grad school when I was taking field geobiology courses. And the reason we went there was because they have these ponds that are really shallow, and they don't circulate well. And because they don't circulate well, like physically, they don't mix very much, those ponds get sort of stratified. You get like different chemicals at depth in the pond than you do at the surface. And as a result of all that, you get like these really weird bacteria growing there that you don't usually find in like the open ocean and stuff like that. And so we went to study those and study how they affected the environment and, what kinds of chemicals that the bugs that were growing in that pond were producing. So like the picture of this is like we're in the Bahamas doing this. And we're usually going with like an undergraduate class that's studying the coral reef. So they're like scuba diving off the coast of the Bahamas for their research project. And I didn't mention this, but these bacteria, they're the ones that make things smell bad.
Oh, no.
So like literally the smelliest place I've ever been on Earth was like these ponds in the Bahamas. And this is what we do for science. But it was in the Bahamas, right? We would be in the muck.
Take one for the team. Yeah.
Yeah, I mean, it smelled like a sewage treatment plant that you were like standing in. And it was horrible, but we loved it. It was fun. Like, it was horrible from like our nose's perspective, but like really invigorating from our brain's perspective, I guess. That's like the weird bimodal nature of a scientist, I guess.
You're miserable, but intrigued. Yeah.
Yeah. And then we'd like cross the street to wash off, and we'd be washing off in the Atlantic Ocean. And then the next day we would go scuba diving and we'd see sea turtles and sharks and stuff. And in addition to all the amazing things that I thought we were doing, like looking at these tiny ecosystems, this is also one of the places in the world with the most pristine coral reef ecosystems, which are dying off as we speak. And so knowing that research was going on by the undergraduates that we were there with was really cool. And in addition to that, this is the island that might have been the first place where Columbus landed. And so there's all this amazing anthropological research going on there on, sort of the first landing of Europeans in the New World on the Western Hemisphere. And it's just a really cool place. And now there's like a Club Med there. And I was like, would I want to take my family there and like be on the Club Med and like get on the bike and go away to these ponds for a day and like just to reminisce? Mm-hmm. I don't know. It was awesome. And there's like one bar on the island, and we'd go as grad students with our faculty, and they would like sing and play with the band at the bar. And it just was a really cool San Salvador Island. Amazing. If I was a faculty member, I would try to take my students back there every year just because it's a lot of fun.
Well, that sounds like a spectacular trip. I love this juxtaposition of these smelly, awful, bacteria-filled ponds with the beautiful ocean and the pristine coral, things like that. So very, very interesting. It sounds like this is really a place where sort of science, history, and culture all collide to make just a phenomenal experience.
Yeah, and I didn't point that out, but the juxtaposition of the combination of the scientists and the culture is actually really important in this case, because the details on the ponds that we were studying were best known until about 10 years ago by the people that lived there. And they're named after the people that currently live there in the scientific literature, because that's who we went to for expertise. it was like one of these small islands where, like, I think it's like the guy that one of the ponds was named after is also the guy that runs the bar, and his brother's the one that catches the fish that they cook at the bar. I mean, it's just, I don't know. It's the one time in my science career where I felt like it was truly like a family endeavor, where, you know, like we were working with a family that, I don't know, it was like their thing.
That is excellent.
It was really neat. Yeah.
Well, it sounds like a phenomenal experience. And I love this little bit that you brought in at the end about the people that you worked with there and the connections you were able to make with the local people doing science with them. And I think the people that you work with in science are such a huge part of what makes it great. You know, whether it's undergraduates, whether it's people in the place you're doing field research, your colleagues, your peers, your mentors, things like that. I think you get to work with just some incredible people. And when you think back over the course of your career and think about these different groups that you worked with, I think it's funny when you look at some of these quirky traditions that spring up and just some funny memories you shared together. I think there is a stereotype, a perception of scientists out there of being very serious, and you take your research seriously, but scientists love to have fun too. So can you share with us today, Shawn, some examples of maybe these quirky traditions or fun memories that you've had in science?
So there's a bunch. One tradition, one of my advisors has a saying that for me, I wouldn't call it a tradition exactly, but it's become a rule. And it's, don't work with blank. And blank is a bad word.
You could substitute bleep, yeah.
Let's say don't work with jerks. That's probably an easy way to say it. Don't work with jerks.
All right.
And that's become almost like a mantra for me when I am team building now. And I will say one of the things I love about being in specific field that I'm in and being in the place that I'm in. So as an astrobiologist, I have to work with a lot of other people. There's no way. It's impossible for me to know all the things I would need to know to do my job well. I would have to get like 5 PhDs.
Right.
And no one has the time or the patience or the financial well-being for that. So I'm not going to do that. Instead, I'm going to get my 1 PhD, and I'm going to work with a bunch of other people that have PhDs or master's degrees or undergraduate degrees that are really good at the things that I know nothing about. And to do that, you have to know that you're working with people that aren't jerks. For a lot of the reasons we've been talking about before. You don't want to be competing with the other people for first author on the paper. You want to have some collegial relationship where you can work it out with them. And then, you know, they get a turn taking the lead and you get a turn taking the lead. So don't work with jerks has become a mantra for me. Now that I'm at NASA, working on missions has been amazing because everybody is so focused. It's almost like we are inherently a team. Mm-hmm. At NASA, like, I think very little about my own CV these days or my own development as a person on a piece of paper. Mm-hmm. I think almost exclusively about the science I want to achieve and the missions that I want to fly to achieve that science. And everything else I do is really in service of that. And then I'm not saying that because I think I'm different in any way. Like, that is how I think just about everybody I work with on a daily basis at NASA operates. We really... I'm almost like a family, and that is awesome because all these other problems just kind of get swept away. Because if it's servicing the mission, we're all sort of on board. And, then, you know, sometimes we'll even strategize for the sake of the mission at the expense of ourselves. And it's liberating. I think my science is better because of that. I think my CV, even though I'm not doing this for the sake of my CV, I think in the long run my CV is going to be better because of this. Because if I bring other people onto my papers because it's what helps the mission, they're going to do the same thing because it's going to help their papers too. And so my CV is going to get better as a result, even though that's not the reason I'm doing it. So I guess that's not a tradition, but like, don't work with jerks and find great teams. It's become almost a mantra for me because it makes everything about my life better. Although, you know, now that you're asking, I kind of feel like a little pressure here. Like, we got to come up with some cool, like, some cool tradition.
You got to get the team together for something fun. Yeah.
Yeah.
Well, I love this description that you're giving about, you know, what's good for the team is good for everybody. So people are contributing to really focus on the success of the team and helping each other out and bringing on people when they're needed to, you know, kind of get things moving, get things going. And I think that's so important in science, you know, certainly at NASA when you're doing these huge missions, but also within small laboratories. I mean, when you think about it, even a laboratory of, you know, 3-4 people, if not everyone's working for the good of the lab, the good of the team, you're going to be in trouble. So
I should say, even though I'm appreciating that right now at NASA, I learned that lesson when I was a postdoc working for Vicki Meadows at the Virtual Planet Lab at the University of Washington. She's the one that really taught the importance of being a team member, but also how you can leverage the team for yourself if you give a lot of yourself up for the team. And it's worked really well for all of her postdocs and grad students, including me. And so, yeah, I think you're right. Whether it's a group, a lot of group of 4 people, whether it's a giant international team or whether it's a whole research community, doing things for the sake of the mission and the science goals that you're really setting out for, I think in the end it really does pay off, even though it doesn't feel that way. There's a lot of times you don't get that sort of immediate benefit. We're always looking for that next publication that
right.
could help your CV. But a lot of times your CV is better off in the long run by not focusing on those near-term goals.
Absolutely. Well, great insights there, Shawn. And I think you're right. You're going to have to work with the folks at NASA, come up with some fun, quirky traditions, and we'll have to check back with you on those.
Yeah, ask me in a couple of years, and hopefully we have one.
Yeah.
If we haven't, then I failed you.
All right. Well, we will have to follow that up. That can be your failure story next time now.
Yeah, that'll be my failure. I couldn't come up with a quirky tradition.
Well, Shawn, I love hearing about this sort of team spirit that permeates NASA. And I think when you're working with great teams, it's wonderful to talk about the research, obviously, that you're doing, but you also come up with these big questions. And I think really easy to come up with these big questions related to space, even some of the ones that you're answering now. But there's always things standing in the way from scientists being able to answer some of these huge questions that they're excited about. And oftentimes it's funding or staff or technology or feasibility, all these restrictions on science. But if we took those away, Shawn, can you tell us what is one question that you are just dying to know the answer to?
Well, I think people could probably guess if they've listened to the rest of the podcast that the one question is, are we alone?
I saw it coming, I'll be honest.
Yeah, so let me try to answer another one, which is related to this one. And this is the one that it's like, it kind of gets at the first part of your question, which is like, so what's the real big challenge, right? What's the limitation? And there's a technical limitation, which I know nothing about. Well, I know a little bit about, but I only know a little bit about it because other people have told me about it. And that's, how do we actually block this starlight so we can see a planet around another world? And that's something the engineers and the instrument design people are working on. The question that keeps me up at night is, how will we know when we see the habitable world, right? Mm-hmm. And how will we not be fooled? If you look at the history of the search for life beyond Earth, we constantly trick ourselves into thinking that life is out there when it's not. It was the case when Percival Lowell looked at Mars and thought he saw, some sort of canal. Now, it's been sort of misinterpreted. I don't think he actually thought that there was architectural canals, but he thought there was water being transported from the poles to the equator. He thought there was vegetation growing around those water features. So he thought he detected life. He was about as wrong as he could be. We then sent the Viking landers with the anticipation that we would find life on the surface of Mars. And when the Viking landers set foot on Mars and they picked up their experiments, 1 out of 3 experiments came back with a positive detection for life. Now, most of the astrobiology community does not think that the Viking landers detected life on Mars, but to this very day, the PI, the lead scientist on that instrument that came out back with a positive detection, thinks that he found life on Mars. And again, this is another case where at least one person thinks they found life elsewhere, but the scientific community remains unconvinced. You fast forward to the Allen Hills meteorite. For those that remember this, in the late 90s, I think it was 1997 or 98, President Bill Clinton, he was the president at the time that this happened, called a press conference for NASA to announce that NASA had found evidence of life in a meteorite from Mars that landed in Antarctica in the 80s. It turns out, after we investigated that meteorite more thoroughly and ways that the signatures of life in that meteorite could be formed without life processes acting on the rock, that there are other ways to describe all the data that they were using to claim evidence of life. And this isn't just about Mars. If we look into the history of Earth and you look at the papers in scientific literature for what is the earliest evidence of life on Earth, if you go back to the earliest dates people claim to have found evidence of life for, those are extraordinarily controversial because there's non-life processes that could create the signatures the geologists and the geochemists are seeing way back then. So I know all this from just having gone through grad school in astrobiology and in geology, and I'm thinking now forward to the future. If I get this huge telescope in space and we look for life on other worlds, and I think I've found it, what do I need to do to convince myself and convince the rest of the scientific community that I'm right about that? And that's what I've really been spending the last years of my life working really hard on, is trying to figure out what I call false positives. What are the ways that nature could trick us into thinking that a dead planet was alive? And that's something that we really need to work out before we design the telescope, because when we build that telescope, not just have the capability to find the things we think are signs of life, but also to discriminate between the non-life processes that can make those signatures and the true biospheres that make those signatures. And so we want to have those sort of secondary search strategies in place and part of the design of the telescope. And so the question of how nature might trick us into thinking the dead planet is alive is to me, the hardest question to figure out when it comes to searching for life beyond Earth.
Well, that is a great question, really a great set of questions that you've kind of just chatted about here. And I think that's a really great point that I haven't thought about in terms of what would it take to convince me? Like you said, a lot of people take this evidence that you provide and you have to say, okay, well, could this have been a non-biological process creating it? You know, what level of evidence or what amount of evidence would it take to really get me to believe it, you know?
Yeah. Well, and you get into things like this where there's many disciplines involved, because this is a question that geologists are going to have a say in, and astronomers both from the observational standpoint and also from the instrument development standpoint. You're going to have biologists certainly weighing in on this, and potentially ecologists and climate scientists. And each one of those communities has different standards of proof. And they might also have different ideas on how this signal could be generated with means other than light. And anticipate people from another field and how they'd react to it is really hard. And really the only way you can do it is not to pretend you know how they're going to do it, is to go up and talk to them about it.
Right.
And so to me, that's sort of the next phase of our progress on this problem, is getting people from these different communities to work together on sort of the standards of proof. You know, what would convince us, not just me as an astrobiologist, what would convince you as a scientist? What would convince you as an individual person? And what would convince people from other scientific disciplines like climate science or ecology? You know, knowing what those standards of proof would be is, I think, critical to making this mission worthy of flying. And that's something we're going to start working on over the next probably 5 or so years.
Well, Shawn, you have given myself and our listeners some excellent food for thought. And listeners, I hope you're out there thinking about what would it take to convince you that there's life outside of Earth. So fascinating, fascinating work.
And I should say real quick, I didn't point this out before, we're not talking about E.T. or like Kodos and Kang from The Simpsons. We're talking about bacterial life.
Right.
So this isn't me saying like I've gotten a radio transmission like from contact. This is how would I prove to someone else that a planet is alive, that a planet has a biosphere. Didn't mean to interrupt. I just realized I never clarified that.
Fantastic. Well, Shawn, great points there and great questions for us to think about. And I think in addition to some of these big research questions that you ponder with your colleagues and mentors and peers, things like that, I think you also get some great advice. And you've shared a couple different quotes or pieces of advice throughout our interview. But I want you to tell us now what you would consider the best piece of advice that you've ever received.
Find something you love and pursue that passion. And that, you know, it's really true in the science for the reasons we've been talking about. When it's competitive, you have to work hard. And if you work hard, you're only going to be able to do that and be happy if you really love what you're working on. But it's like, you know, taking a broader look at things, it's not like science is special, right? It's not like science is the only area of the economy that is competitive. But the world is competitive. And whether you're a scientist or whether you're in business or whether you're in some other area of research or whether you're opening up, you know, your own corner store somewhere, whatever you're doing in life, people are going to be competitive at some level, and that's human nature. And that means you're going to have to work hard to be successful. And in my opinion, that means you need to find something you really love to do, because if you love it, it's going to be easier and happier to work hard at it. So to me, that's a big piece of advice. Find something you love and go after that. You may not succeed, but at least you'll have fun trying and work hard.
Very well said. Shawn, I love that advice. Now, is there any other last piece of advice or maybe any last piece of inspiration that you want to leave our listeners with today, now coming from you personally?
I think I've said a lot of the things that sort of motivate me. I think the only other thing I'll say is just be excellent to each other. It can be hard sometimes when you're in the trenches and you're working hard. And if we're not really good to each other as scientists, it just makes things that much harder. And so just be nice to each other when you're working on things, and you're going to be more productive as a result. Well, that is brilliant advice. It takes us back to those lessons we learned in kindergarten, right? Be nice to each other. Yeah. Oh, by the way, I heard that they're coming out with a sequel to the Bill and Ted's Bogus Journey. So my culturally dated reference may be culturally relevant again in a couple of years. So I'm either way behind the times or I'm way ahead of that. I'll let your listeners decide. Fantastic. Well, Shawn, thank you for sharing these pieces of advice with us today. And thank you for sharing so much with us today about your research, about your story. Can you tell us how our listeners and myself can go out there and learn more about your research? Well, the best way for my research is probably to go to the Virtual Planetary Laboratory's website. And the best way to find it is to Google it. I think it's detail.astro.washington.edu. But if you can't find it, just Google Virtual Planetary Laboratory. they really are the world's leaders, in my opinion, in doing research on how to find life on planets beyond our solar system. For the search for life more broadly, if you're interested in Mars or Europa or anywhere else, including the extrasolar planets, go to astrobiology.nasa.gov or look up the Astrobiology magazine. And you can also check out a blog that I manage called Pale Blue Blog. That's paleblueblog.org. With Carl Sagan's Pale Blue Dot. All those would be great resources, and I encourage all your listeners to check all of them out.
Spectacular. Well, Shawn, we will definitely check out these resources. And thank you so much for joining us today and sharing so much of your story.
Thank you, Maria. I really, really appreciate being on, and I love what you're doing to bring sort of the people side of science to other people.
Well, thank you so much. This has been a pleasure. And thank you to our listeners out there as well. Join us again next time for another episode of People Behind the Science. Your voyage to the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to seeing you next time on People Behind the Science.